Despite all the gains made by science in recent years, lab test results are not perfect 100% of the time. Sometimes samples may get switched at the lab. Sometimes what they're testing for is present, but there's not enough of it for the test to catch it. And we've all heard stories about someone who ate a poppy seed muffin and then got a positive drug test result. So sometimes other things can affect it as well. When the test results are something that's going to have a major impact on our lives, it's important to understand these issues and how the tests work.
Each type of test has several values that describe how well they work. Two of these are sensitivity and specificity. They're calculated empirically by the test manufacturer before the test can be used in labs. Sensitivity is the test's ability to correctly identify samples with the particular condition, and specificity is the test's ability to correctly identify samples that do not have the particular condition. A cancer test with 99.7% sensitivity will correctly identify a patient with cancer 99.7% of the time. 0.3% of patients with cancer will get a false negative result. The lab will say the patient does not have cancer, but the lab is wrong. A test with 92% specificity will correctly identify 92% of cancer-free patients, but 8% of patients who do not have cancer will get a bad scare, a false positive.
There are many reasons why doctors and patients need to be aware of this. Medical treatments can be very expensive, and they can be quite dangerous if the patient doesn't actually have the condition that they're being treated for. So tests with a low specificity need to be redone to be sure that the patient actually has the disease, to help weed out false positives.
Let's take a look at an example. You may want to write these numbers down on your own paper as we go through this so that you can follow along. Jen manages a chain of clothing shops with a total of 276 employees. She has decided to have her employees randomly take drug tests so that she can maintain a drug-free work environment. She knows that in general, 8% of people who work in retail use illegal drugs, and 92% do not. When the test results come back, Jen is surprised and saddened to see that Clarissa, one of her best employees, had a positive result. A typical urine drug test has a sensitivity of 38.2% and a specificity of 98.8%. This is a high specificity. Should Jen fire Clarissa? 8% of Jen's employees can be assumed to be drug users. 8% of 276 is 22 people who use drugs. Of those 22 illegal drug users, 38.2% of them will have a positive test result. 22 times 0.382 comes out as 8.4, or 8 people. The drug test catches 8 users. These are true positive results. The remaining users will have a negative result. The 22 users minus the 8 people who got caught are 14 people who used drugs but got a negative result. These are called false negative results. Now, 92% of Jen's employees can be assumed not to use illegal drugs. 92% of 276 is 254. Of those 254 people who do not use drugs, the test correctly identifies 98.8% of them. So 98.8% of 254 is 251 people. The test correctly identifies 251 people who do not use drugs. The remaining people who don't use drugs get a positive result due to an error at the lab. 254 non-users minus the 251 who were correctly identified, leaves us with 3 people who got a positive test result even though they don't use illegal drugs. These people who are falsely accused are false positives. A total of 11 employees were identified by the test as using drugs, but 3 of those people are actually innocent. Written as a probability, 3 out of 11, or 27.3% of the positive test results are actually false positives. Jen needs to take this into consideration when deciding what to do. She may want to retest employees before firing them so as to avoid losing good employees over a lab mistake. Or she may decide that retesting everyone with a positive result is too expensive and she'd rather let Clarissa go. But at least knowing how this works, she can make an informed decision.
The main thing to remember is that lab tests are not always right. If it says you have cancer, it might be wrong. And whether or not you do actually have cancer doesn't change just because of the lab result that you got. It's more important to get a correct lab test result than one that says you're healthy if you're not.